Using the total area of a cube formula is very simple and straightforward because a cube is made up of 6 squares which are identical to each other. So if we know the area of a square formula, A equals S squared, and we calculate the area of one of those squares, we just have to multiply that answer by 6, and we must have the total area of the cube, the area of the 4 side walls plus the top and the bottom. Let's look at a couple of examples. In this case, we are asked for the total area, and we are given a side length of 5 centimeters. So let's plug a side length of 5 into the total area of a cube formula. The S is replaced by a 5. Remember your rule of BEDMAS that exponent must be done before multiplication. So do not multiply 6 by 5 first. Square the 5 first. 5 squared is 25. And 6 times 25 is 150. Because we were dealing with centimeters as our measure of distance, the area unit will be centimeters squared. The only other way to use this formula is if you know the area and you are looking for the side length. In this case, we have a total area of 24 meters squared, and we are being asked for the side length. So plugging the 24 into the A position in the formula, we get 24 equals 6s squared. Divide both sides by 6. These cancel. S squared is isolated and is equal to 24 divided by 6, which is 4. We're not finished. We want to know the side length S. If S squared is equal to 4, then S is equal to the square root of 4, which is 2. Since our unit for area was meters squared, the unit for distance must be meters. The side length in this cube is 2 meters. One way that I can try to make a question involving the use of this formula a little more tricky, to impose an extra step or two, is if I am asking for the total area of this cube, but instead of giving a side length, I give the area of the bottom, which is 9 millimeters squared. Well, the bottom is a square, and the area of a square formula will apply, so I can find the side length using this formula. If the area of the bottom is 9, my A is replaced by a 9. We have 9 equals S squared. S will therefore be equal to the square root of 9, which is 3. And now I can plug that 3 S length into the area total formula. I get AT equals 6 times 3 squared, which is 6 times 9, which is 54. The unit of measure was millimeters squared, so this is still an area. It will also have a unit of measure millimeters squared. A shortcut can be to realize that the area of the bottom is equal to S squared. So that means the 9 millimeters squared area of the bottom is equal to the S squared in the total area formula. I can just directly plug 9 into my S squared position. And I have a total area of 54 millimeters squared. Here's another slightly tricky version of this question. In this case, I'm given a total area of 6 centimeters squared for the cube, and I am being asked for the area of the bottom. If we know the total area is 6, the AT in this formula can be replaced by 6. Now we use algebra to isolate our S and find our side length. If we divide both sides by 6, these cancel. S squared is isolated, and 6 divided by 6 is 1. But we want S, not S squared. If S squared is equal to 1, S will be equal to the square root of 1, which is still 1. Since the area was centimeters squared, the side length will be centimeters. Now we can plug the side length of 1 into the area of a square formula to answer our question. Area is equal to 1 squared, and 1 squared is 1. Our answer is 1, and the unit of measure, because we were dealing with centimeters and centimeters squared, and this is an area, the unit of measure will be centimeters squared. So one thing that makes this question a little bit tricky is that we're being asked for the area of the bottom, but not given the side length. We have to find the side length by using the total area formula. And the other thing that makes it tricky is that because the side length was 1, we end up with this situation where we have 1 squared and the square root of 1. The answer 1 keeps coming back. If we're not confident, this can fool us into thinking that we're doing it wrong.